Good evening, everybody. This is Varshastri from Mechanical Department. So, in the subject of B3B, I'm going to explain about MCB and ELCB. Generally, MCB and ELCB are the safety devices used in electrical machines to protect against the overcurrent and short circuit. So, coming to MCB, MCB is abbreviated as miniature circuit breaker. So this is a safety device where it automatically switches off the electrical machine or electrical circuit to protect from the abnormal condition. So here abnormal condition means there is a overcurrent or short circuit. So here it is mentioned it is overcurrent or short circuit. Okay, overcurrent in the sense there is a excess amount of current is flowed, and short circuit in the sense there is a high amount of current flow. So to avoid from these conditions, the MCB switches off the circuit and make sure the circuit is in safe condition. Now, and here they mentioned about it is a more efficient than the fuse. So this means when in the case of fuse, when there is a short circuit, generally the fuse melts off and we need to replace with a new one. But whereas in MCB, we need not replace with there is a no purpose of replacing with the new one. It automatically switches off and we manually need to switches on the circuit again. So it has electromechanical mechanism in the sense there is a mechanism inserted in the circuits. So I will explain about this later in the next slide, and it is less cost. Now, circuit diagram of overload protection. So this is the circuit diagram of overload protection where it contains bimetallic strip. So this is the bimetallic strip. This is the trip bar. Okay, and this is the phase. So this is the phase where the current flows from the phase to the contact, I mean to the load. So here it is the contact. So the first picture, this one is the normal load. Okay, this one is a normal condition, sorry, this one is a normal condition, and this is the abnormal condition. Abnormal condition means there is a overflow of current. In normal condition, the current flows from the phase. Okay, the current flows from the phase and to the bimetallic strip and to the contact, I mean to the load finally. And the in normal condition the circuit is safe. Now coming to the abnormal condition. So in abnormal condition, when excess amount current flowed. Okay, when excess amount of current flowed, this is the bimetallic strip, right? When excess amount of current flowed, the bimetallic strip generally expands. When it is expand, it touches the trip bar. Okay, you can notice here in normal condition the trip bar is in straight line, and here it is bended somewhat. So this because when the overcurrent is flowed, when overcurrent flowed, the bimetallic strip expand and it touches the strip bar. When it touches the strip bar, there at the end the contact is lost. So there is no contact between the load and the circuit. When there is no contact between the load and circuit, there is no current flow. Okay, when there is no current flow, the current is in the device, I mean the circuit is in safe condition, right? So in this way it protects the circuit. Now next, short circuit protection. So in the main difference between the overload protection and short circuit protection is in short circuit protection there is a presence of solenoid. This is solenoid. Generally they mention magnetic element. So this solenoid is wounded with the copper coil. Okay, this coil is made up of copper, and the principle is same. This up one is a normal condition and this is the abnormal condition. Okay, this is the abnormal condition. So the main difference you need to notice at contact. This is the contact, right? This is the contact closed and this is the contact open. So in this case, in normal case, when the current flowed, okay, when the current is flowing from here, and this is called as plunger. Okay, when the current is flowing in normal, see current flows from here, and it reaches the magnetic element, I mean solenoid, and it reaches the contact. Okay, in this normal case, everything is fine. And coming to the abnormal case, so the current flows as usual in the normal case one. But here overcurrent is flowed. When this overcurrent is flowed, there is a generation of magnetic field. So when the magnetic field is generated, it pulls the plunger towards it. Here the generation of magnetic field. So this it pulls the plunger towards it. Okay, the plunger moves towards the magnetic element. When it moves towards the magnetic element, this strip bar also displaces. When it displaces, here there is a presence of MCB switch. It offs. When it offs, there is no contact. See here, when there will be contact is open. So as the contact is open, there will be no flow of current. The device in safe mode. Next, the features of MCB. It is overload protection and it is short circuit protection. We have seen it already. We have discussed it, and it is resettable. So I said with the example, right? Like fuse. Fuse is we need to replace it with a new one all the time, and whereas MCB there is no need of like that. And current rating, so current rating, MCBs come in different current ratings. For example, like they have given the example 6 amperes, 10 amperes, up to 32 amperes. Okay, next, applications. Okay, so these are generally used in homes, commercial buildings, okay, industrial settings, and etc. Now, let's say about ELCB. So the main difference between MCB and ELCB are they works similarly, but the main difference is ELCB detects the current leakages. So it detects the where current is leaked, and but the working principle is same as working principle is same as MCB. Now there is a two types of ELCBs. One is a voltage ELCB. Okay, this is the circuit diagram of voltage ELCB. This voltage ELCB consists of circuit breaker. Okay, circuit breaker, here it is, and there is a three phases R, Y, and B, and N also. Okay, there is a load, there is a relay, and relay is connected to ground. Now, whenever in normal condition, we uh, send some amount of current from these three phases. Okay, from these three phases, and the current is received by the load in normal condition. Okay, the current is received by the load, and the same current is taken by the and neutral phase. So here there is no loss of current. So in abnormal condition, the current the three phases sends the current to the load, but at the load there is a leakage of current. Okay, there is a current leakage. Okay, so current leakage at the load. Here at the load there is a current leakage, and when there is a leakage at the current leakage at the load, the same amount of current is not sent to the neutral, right? So as this relay is connected to the load, the leaked current at the load will taken by the relay. The leaked current will move to relay, and that leaked current, this relay sends the leaked current to the ground. Okay, and this is also connected to CB circuit breaker. So this relay sends to the circuit breaker signals by saying there is some current leaked at the load. Okay, so the purpose of the purpose of circuit breaker is it actually trips off the circuit when there is a current leakage. Okay, next, let's see about current ELCB and RCCB. So this current ELCB is also called as RCCB, residual current circuit breaker. And let's see the circuit diagram of it. So this current ELCB consists of the windings. So here it is the windings. Here there is the windings, and there is a trip coil, and here you can see the circuit breaker. This is open, this open, there is no flow of current actually, and actually it is shown in the abnormal condition. In normal condition, the circuit will be here it is actually closed. Okay, here in these two phases, here actually it is closed, but it is showed in abnormal condition. Okay, it is showed in abnormal condition, and when the current flows from here, in normal condition there will be no changes. Okay, the circuit will run properly without any overload or short circuit, without any excess amount of current flows. But in this case, in abnormal condition, when the current flows from here, and the current flows in the ear windings. Okay, this circle one is there, right? It is a magnet. It is a magnet. As the copper, as copper is wounded around the magnet, when there is a flow of current, it generates magnetic field. When it generates magnetic field, it pulls the trip coil towards it. Okay, when it pulls the trip coils towards it, the circuit breaker, here it is open, right? The circuit breaker will be open. So very simple. So when the magnetic field is generated, it pulls the trip coil towards it. Okay, it pulls the trip coils towards it, and when it pulls, the circuit will be open. Okay, on both sides the circuit will be open. So in this way, the circuit is protected. And next, coming to the application, ELCB is used for home safety. Okay, and industrial and commercial use, prevent fire hazards and etc. And so this is today's my topic.